Hi, welcome to video 6 of my 8 to 12 part, I don't know exactly yet, series of videos on linear relations, overarching themes, etc. Today we're going to be looking at determining slopes of lines just from points. We're going to backtrack a little bit here. Last time we spoke about the general form of equations of lines. We had taken it from a specific scenario and then extended the dependent variable to y. So I believe the last example we had something like c equals 250 plus 20n, and we extended this then in general forms to y equals 250 plus 20x. And so then the extended on, we took a look at rate triangles to determine what the graph, the slope of the graph would look like. And so what we did is we took some sort of known points and we drew the legs of a rate triangle, legs of a right triangle, which is then a rate triangle, and to determine the slope of the line. Okay, and that was the rate of change of the cost of the banquet. And here we found that that was, of course, the slope that we were looking at in this case. And we found the slope to be 20, and the rate of change for this scenario, rate of change of cost, was 20. Okay, so we looked at that in one of the last videos. And so in this rate of change, or in this rate triangle, we looked at the delta y, which is the change in the y value from one end of that triangle to the other end. And in this case, the rate of change, or the delta y, would be, well, 10 minus 4. That change as we go from this point on the graph up to this point in the graph, we see that the delta y, the vertical change, is 10 minus 4, which gives us a value of 6 for the delta y. And the delta x, when we take this from the x value at the beginning of the triangle to the x value at the end of the triangle, so that would give us 4 minus 2, and that gives us a delta y of 2. So then our slope, the slope of the line, we were looking at this in multiple forms or multiple representations. We were saying that this delta x could be considered the run, and the delta y was considered the rise. And because the x values are the independent variables, the y values depend on the x values. So depending on how many steps we move across in the independent variable, that would be the number of steps we rise in the dependent variable from one end of this one section to the other. So our how much the graph rises in relation to how much the graph runs will give us the slope of the line. And so our rise over run, we know the rise corresponds to the delta y. And actually, I'm going to change this just briefly so the color coding can correspond. And so the run is delta x, and then delta y, we saw, well, just from this scenario, this 10 is y2, because this point, we can consider this point P2, so it's the second point we're considering, and it has coordinates 4 and 10, and the y value of that point is 10. and then the y value of the first point down here, which we'll call P1, is the coordinates are 2 and 4. So the y1, the y coordinate of point 1 is 4. So we labeled the x as x1 and the y here for point 1 is y1, and then the x from point 2 we called x2, and the y from point 2 we called y2. And then so the delta y, the change in y, would be the difference between y2 and y1. Keep in mind, of course, again, that those values, the 2's and 1's are subscripts indicating which point they come from, and they're not exponents. And then the delta x is the difference between x2 and x1. So then we just have to substitute in those values. So the y2 is this 10 from the y value of the y coordinate of point 2, and y1 is the y coordinate of point 1, so it's 10 minus 4, and then the x value, x2 of point 2, sorry, I should put actually that value in. The x value is 4, and the y, or the x value from point 1 is 2. So when we simplify all that, 10 minus 4 is, of course, 6. 4 minus 2 is 2. And so we get a slope of 3. Next little scenario is that what if we don't actually have a graph and we're not using a rate triangle, we're not finding points from a line itself. What if we're actually just given points? So suppose we say the question is something like, determine the slope of the line through points 2, 5, and 7, 12, for example. So we have 2 points here. This would be point 1, this would be point 2, and of course from point 1 we've got x1, y1, and from point 2 we've got x2, y2. So we don't have a graph to go with, but we do have the formula, and we've got 2 points. So from the formula we knew it was rise over run, formula for slope, that is, rise over run, delta y over delta x. And I will write that part. Sorry, that y did not turn out very well. And delta y we know is the change in y values, and the delta x is the change in x values. So we just have to take the x values and the y values appropriately. So it doesn't matter which is y1 or which is y2, which I showed you in one of the previous videos, but I'll take this as y2. So I'll take 12 as y2, and then I'll subtract the y1 from the point 1, and then I'll take x2. So I have to make sure that the x value that I start with is the same, from the same point that I started with the y value. And then I'm going to be subtracting off the other x value from x1, and then just subtract. So 12 minus 5 is 7, 7 minus 2 is 5. Therefore, the slope of the line is 7 over 5, which means that for every 5 units that we go to the right horizontally, the graph is increasing 7 units up. Okay. If we have some other scenario, we've got another another line that crosses through 2 other points. The line passes through points, say, negative 5 and 8, and let's say it passes through 3 and negative 6. Okay, so a line is passing through those 2 points. We've got point 1, we've got point 2. Okay, and so we know slope is delta y over delta x. We know that delta y is y2 minus y1 over x2 minus x1. And like I said before, it doesn't matter which one you start with. This time I'm going to start with point 1. So the y value from point 1 is 8 I'm subtracting the y value from 0.2, which is -6. I'll put that in brackets because it's negative. And that's going to be going over -5, which is the x value from 0.1, minus 3, which is the x value from 0.2. 8 minus -6 is 8 plus 6. And -5 minus 3, I could just do that right now if I want, it's -8. And 8 plus 6 is 14 over -8. And then I can simplify this. And so I will get -7 over 4. Okay, which means that for every 4 units, I go to the right in the x direction. That means that the graph is decreasing 7 units in the y direction. Okay, and this tells us it's negative slope, which means in general, if I were just to do a quick sketch of this, in general, the graph's going to be going down from left to right. Meanwhile, the other graph over here, if I were to quickly draw this as a quick sketch, for every 5 units I go to the right, the graph is going up 7 units, so it'll be in that sort of form. I don't know what the y-intercept is, I'm just guessing, just kind of drawing a line that could represent that slope. Okay, and that's basically it. So when you have a line passing through 2 points, 0, 3 and 8, 12, then again we can find the slope going through those 2 points. Delta y minus delta x, delta y over delta x is x2 minus y2 minus y1 over x2 minus x1. This time I'll start with the second point, 12 minus 3 over 8 minus 0, and I get 9 over 8. Okay, it's a positive slope, and this time the graph is going to be going something like that. Okay, so as we move along in the x direction, as we look along the line in the x direction, we see that the graph is increasing. Okay, so we go along the x, up, to the right in the x, up, over, up. Okay, so that's basically how that would be done. So thanks for watching, and we'll see you in the next video.